Hello students, welcome to Sir's classes. We are solving the paper of IIT JAM Statistics 2017 and the question in hand is let AN and BN be sequences of real numbers such that AN is increasing and BN is decreasing. Under which of the following conditions the sequence AN plus BN is always convergent? Suppose, note that this is a multiple select questions and hence we have to evaluate each option separately. Since you know that BN is decreasing and AN is increasing. Suppose AN is bounded above and BN is bounded below. This implies that AN plus BN is bounded on both sides, and by Weierstrass theorem, by the Bolzano-Weierstrass 3C theorem, AN goes to some A and BN goes to some B. Both of them converges, which also implies that AN plus BN goes to A plus B and it converges. So A is correct if AN and BN are bounded sequences. Suppose AN is bounded above. Take AN equal to 1 and BN equal to minus n. AN plus BN equal to 1 minus n, which goes to minus infinity, and it's not convergent, so B is wrong. AN is a bounded sequence and BN is bounded below. Let us check. For D, AN goes to infinity and BN goes to minus infinity. Let us see. So for D, we can take AN equal to n square and BN equal to minus n, which gives us AN plus BN equal to n square minus n equal to n into n minus 1, which goes to infinity. So AN plus BN does not converge and hence D can be crossed out. The only thing remaining to check is AN is a bounded above and BN is a bounded below sequence. Does it imply that the sequence AN plus BN converge? Now AN is increasing and bounded above, which by Bolzano-Weierstrass theorem gives us that AN increases to some A. BN decreases and bounded below. Again by Bolzano-Weierstrass, BN decreases to some B, and both of these AN and BN are convergent sequences. So AN plus BN goes to A plus B and hence it converges. So C is correct. So we see that A and C are correct answers and B and D are wrong answers. Let us move on to the next question. It says f from close 0, 1 to close 0, 1 be defined as follows. X if x is rational, x plus 2 by 3 is if x is irrational in the interval 0, 1 by 3, and x minus 1 by 3 if x belongs to irrationals in the interval 1 by 3, 1. The options are f is 1, 1 and onto, f is not 1, 1 but onto, f is continuous on q intersection 0, 1, f is discontinuous everywhere on 0, 1. So we will start by checking the 1, 1 and ontoness. Now in 0, 1 intersection Q, f is 1 1 and on to. This is simply because rationals are taken to rationals and it's around 1 1 and on to function on the rationals. Now f of 0 comma 1 by 3 intersection q complement is equal to, now since 2 by 3 is always added to x, therefore before this x less than 1 by 3 greater than 0 implies x plus 2 by 3 less than 1 greater than 2 by 3. Therefore f of q complement intersection 0 comma 1 by 3 is equal to 2 by 3 comma 1 and 1 by 3 less than x less than 1 implies x minus 1 by 3 less than 2 by 3 and greater than 0. Therefore f of q complement intersection 1 by 3 comma 1 is equal to 0 comma 2 by 3. Now the interval 0 comma 1 by 3 is taken to the interval 2 by 3 comma 1 and all irrationals are mapped here, and the interval 1 by 3 comma 1 is taken to the interval 0 comma 2 by 3 and all irrationals are mapped here. Therefore we see that f is 1 1 and on 2. Immediately A is correct and B is wrong. Now we have to check continuity of Q in Q intersection 0 1. So f is either continuous on all points or it's discontinuous. We have to check if it's continuous on all points or it's discontinuous on all points. So 0 at any point A, sequence xn of rationals such that xn goes to A and sequence yn of irrationals as yn goes to A. Now f of xn equal to xn, which is going to A, therefore f of xn goes to A, and f of yn equal to yn plus 2 by 3 or yn minus 1 by 3, which ultimately goes to A plus 2 by 3 or A minus 1 by 3, and A is never equal to A plus 2 by 3 or A minus 1 by 3. Therefore we have a discontinuity everywhere. We just take a point, take a sequence of rationals, take a sequence of irrationals, both of them when applied f, we get different limits, hence we see that it's discontinuous everywhere. So D is correct and immediately C is wrong. So this is how we solve this problem. Thank you.